This is a video from the Exam 3 review. We're going to look at 7G. We're going to determine whether or not this series converges or diverges. And it's the summation from n equal 1 to infinity of n to the n over 3 to the 1 plus 3n. And so a sub n is n to the n over 3 to the 1 plus 3n, which is positive for n bigger than or equal to 1. And so I want the limit as n goes to infinity of the nth root of n to the n over 3 raised to the 1 plus 3n. Okay? Now, this is the limit as n goes to infinity of, we get the nth root of n to the n divided by the nth root of 3 to the first times 3 to the 3n. Okay? The nth root of n to the n is just n. So this is the limit as n goes to infinity of, we get n on top, we get 3 to the 1 over n times 3 to the 3n over n. But this is equal to the limit as n goes to infinity of. Now we get n over 3 to the 1 over n times 27, because the n's cancel and 3 to the cubed, or 3 to the third is 27. But this is equal to infinity. And so what that's going to tell me is that the summation from n equal 1 to infinity of, and if we look back, it's n to the n over 3 to the 1 plus 3n diverges by the root test. And that's how we do 7G. 7H. Suppose we have the summation from n equal 1 to infinity of sine of pi n over 2 divided by n to the 3/5. This one is a little deceptive, okay? But I need you to watch something here. If I let n equal 1, sine of pi over 2 is 1, right? I'm just going to rewrite this a little tiny bit. So this is n pi over 2. So when n is 1, we get 1 over 1 to the 3/5. When n is 2, 2 pi over 2 is pi, sine of pi is 0. So I'll put plus 0 for effect. At n equal to 3, we get minus 1 over 3 to the 3/5. Plus 0, right? When n is 4, sine of 2 pi is 0. When n is any even number, I claim you're going to get 0. When n is 5, you're back up to 1. And so it's 1 over 5 to the 3/5. And it keeps going. And so I claim this is the summation from n equal 1 to infinity of. Now, in the denominator, notice how we have an odd number to a 3/5 power. To represent an odd number, we're going to do 2n minus 1 to the 3/5. And if you look at the top, remember, you want it to alternate signs. You want to go from positive to negative to positive, back to negative, etc. And so to represent that, it'll be -1 to the n minus 1. So I claim this series gets transformed into this because you're just adding up the odd terms of the series. Now we can apply the alternating series test. Now my a sub n is 1 over 2n minus 1 to the 3/5. Okay? Now, the limit as n goes to infinity of a sub n is the limit as n goes to infinity of 1 over 2n minus 1 to the 3/5. But that's equal to 0. So condition 1 is met. Now, a sub n is 1 over 2n minus 1 to the 3/5. Okay? A sub n plus 1, I'm going to replace n with n plus 1. So we get 2 times n plus 1 minus 1 to the 3/5. Okay? Now, I claim this is 1 over 2n plus 1 raised to the 3/5. Just like this. Now, can we agree 2n minus 1 is less than or equal to 2n plus 1 for n greater than or equal to 1? That's a fact, right? So if I raise both sides to the 3/5, it still holds. Okay, now from here, if I take the reciprocal, do we agree the inequality gets switched? And in fact, it does. And so this says an is bigger than or equal to an plus 1 for n bigger than or equal to 1. So by the alternating series test, the summation from n equal 1 to infinity of -1 to the n minus 1 divided by 2n minus 1 to the 3/5 converges. Okay? But, so I'm going to put but, the summation from n equal 1 to infinity of sine of n pi divided by 2 over n to the 3/5 is the same as the summation from n equal 1 to infinity of -1 to the n minus 1 over 2n minus 1 to the 3/5. They're the same series. And so that implies the summation from n equal 1 to infinity of sine of n pi over 2 divided by n to the 3/5 converges. And we're done. And that was 7H. Yes. Okay. Let's take a look at 7 part I. Well, suppose we have the summation from n equal 1 to infinity of n squared plus 8 divided by. And in the bottom, we get the cube root of n to the 10th plus n to the 5th. Something like that. This is what I would do. I would let an equal n squared plus 8 divided by the cube root of n to the 10th plus n to the 5th. This is a classic limit comparison test. So I'm going to look at the term in the numerator with the highest degree, which is n squared, and the term in the denominator with the highest degree. Within that radical, it's n to the 10th, right? Within the radical. So I'm going to divide by cube root of n to the 10th. But this is n squared over n to the 10 thirds. Okay? Which is 1 over n to the 4 thirds. Now, we're in the home stretch. So I'm going to take the limit as n goes to infinity of an over bn. This is the limit as n goes to infinity of. Now I get n to the 4 thirds times n squared plus 8 divided by the cube root of n to the 10th plus n to the 5th. So that's the limit as n goes to infinity of. Now 2 is 6 thirds, right? So this is n to the 10 thirds plus 8n to the 4 thirds. That's on top. On the bottom, we get the cube root of n to the 10th plus n to the 5th. So it's not obvious, okay? And so what I'm going to do is I'm going to go back a little tiny bit. I'm going to factor out the n to the 4 thirds. So we're going to need that to help us evaluate the limit, okay? And we're going to factor out an n to the 10th within that radical. And let's just see what we get. So this is the limit as n goes to infinity of. So I get n to the 4 thirds times n squared plus 1, right? That's the top. On the bottom, I'm going to take the cube root of n to the 10th times 1 plus 1 over n to the 5th. And so this is the limit as n goes to infinity of. Now I get n to the 4 thirds times n squared plus 1 divided by n to the 10 thirds times the cube root of 1 plus 1 over n to the 5th. It is lengthy. Now remember, 10 thirds minus 4 thirds, that's equal to 2. And so this is the limit as n goes to infinity of. I get n squared plus 1 divided by n squared cube root of 1 plus 1 over n to the 5th. Okay? And we could do something else here. So this is the limit as n goes to infinity of. Now, if we look, I'm going to take n squared plus 1 divided by n squared. That's the top. The bottom doesn't change. It's the cube root of 1 plus 1 over n to the fifth. And after all that work, I claim that's 1, which is positive. Okay? After all that work. Now, the summation from n equal 1 to infinity of 1 over, and let's remind ourselves, we compared it to n 1 over n to the 4/3. So the summation from n equal 1 to infinity of 1 over n to the 4/3 converges. Why? It converges by p-series. P equals 4/3, which is bigger than 1. So what that tells me is the summation from n equal 1 to infinity of n squared plus 8 divided by the cube root of n to the 10th plus n to the 5th converges by the limit comparison test. And that's how we do problem, this is 7I. 7J. Suppose we have the summation from n equal 1 to infinity of negative 1 to the n times the square root of n over 1 plus 2 square root of n. Okay, now, I want you to pay attention to a sub n. This problem should be pretty short. A sub n is square root of n over 1 plus 2 square root of n. If I look at the limit as n goes to infinity of square root of n over 1 plus 2 square root of n, this is the limit as n goes to infinity of square root of n over, if I factor out the square root of n, I get 1 over square root of n plus 2. Okay? And this is the limit as n goes to infinity of, we get 1 over root n plus 2. Now, this is equal to 1/2, which doesn't equal 0. So if the limit of the absolute value of if the limit of the ands doesn't equal 0, therefore, if I take the limit as n goes to infinity of negative 1 to the n over times square root of n over 1 plus 2 square root of n, this doesn't equal 0 also. And so that implies the summation from n equal 1 to infinity of negative 1 to the n times square root of n over 1 plus 2 square root of n. This guy diverges by test for divergence. And that's how we do 7J. Can we do 7K? On 7K, we have the summation from n equal 3 to infinity of 1 over n times natural log of n. Now, what I'm going to do is I'm going to let f of x equal 1 over x ln x on 3 to infinity. So f is continuous and positive on 3 to infinity. Now, one thing you can keep in mind is that g of x, which is x ln x, is increasing. On 3 to infinity. Because, note, g prime of x is 1 plus natural log of x by the product rule, which is positive on 3 to infinity. And that's why the function g is increasing. But if g is increasing, that implies f of x, which is 1 over x ln x, is decreasing. On 3 to infinity. So the integral test applies. And so I'm going to look at the integral from 3 to infinity of 1 over x ln x dx. And remember, on the test, I will ask you to do an integral. So I'm going to look at the limit as L goes to infinity of the integral from 3 to L of 1 over x times 1 over natural log of x dx. But this is the limit as L goes to infinity of. Now remember, this is u, right? The natural log of x. My du is 1 over x dx. And so this is natural log of x evaluated from 3 to L. So this is the limit as L goes to infinity of natural log of L minus natural log of 3. But that's infinity. And so therefore, the integral from 3 to infinity of 1 over x ln x dx diverges. And so that implies the summation from n equal 3 to infinity of 1 over n ln n must also diverge by the integral test. And that's a good stopping point for this video. This is a video from the Exam 3 review. We did 7G, 7H, 7I, 7J, and 7K. Okay, thank you.